Okay, today I'm going to be solving a really interesting interview question that I found about perimeters of nth regular polygons. Let's dive straight in. So, I guess a good way to start doing this question is just finding the perimeter of the first couple of nth-sided regular polygons, I guess. So, with our triangle, I guess that's pretty much the easiest one. We're going to have here, this is going to be, this angle here is simply pi over 3. And I know that the area of any triangle is going to be a half AB sine C. So in this case, I'm going to have a half times a third squared times sine of pi over 3. So this is going to give me a half times 1 over 9 times sine of pi over 3 is 1, 2, 3, I think root 3 over 2, if I'm not mistaken. And so this is going to give us root 3 over 9 times 2, 18 times 2, 36. If I'm not mistaken. Let me just double check that I did that right. Yes, I did do that right. Okay, our next one. The square is a bit trickier, right? We have to do a little bit more work. But I think what we can do is we can use the fact that any regular polygon can be broken up into different triangles, right? So what was another way that I could have found the area of this triangle? Well, I could have considered the midpoint of this triangle, right? And I knew what that angle was going to be. That angle is simply going to be 2 pi, which represents an entire circle, but I want a third of it, right? So this is going to be 2 pi over 3. And then I could have found these lengths here, let's call them r, if I knew the perpendicular distance from any two sides, right? Any two edges. And so I can use a similar idea here. So if I consider the center of my square, and I draw some lines here, then I have the midpoint. I know this is a 1/2. What else do I know? Well, I also know that this is 1/2. I know that since this angle here is 2 pi over 4, which is just pi over 2, I know this angle here is pi over 4, right? And so I can find this height, and then once I know that height, I could... Oh no, sorry, I already know this height, so I need to find this height so that I can find the area of this triangle and multiply it by 4, right? And I'm not going to do that for this square, but hopefully you can see that this idea continues for the 5th polygon. So for the 5-sided polygon. So we're going to have, here we have our pentagon here, have our center. And we can see that we can simply break up our polygon into these different congruent triangles in which we have exactly n over 2 of these right angle triangles, but exactly n, so 1, 2, 3, 4, 5 of the triangles whose areas we're trying to calculate. Remember, we're only trying to find this length r, because that will help us find the area of one of these triangles. And if we multiply that by n, which is the number of sides, the number of edges, we will get the area of that polygon. So let's try and generalize this idea, because we want to find an expression for an in terms of n, right? So really, we only need to consider the triangles that we're going to sort of build up our polygon. So if I know, if I go back here, so I'm only considering, in this case, this triangle, in this case, this triangle. I know that this angle here is going to be 2 pi over n, right? And I'm going to call this length r, I'm going to call this length r. Because I essentially have 2 pi that represents an entire circle, and I have n edges around my circle that are equally spaced. So you can imagine, for example, if I had, with our 4 case, so with our square, I'm splitting my 2 pi into 4. Okay, and that's what gives me pi over 2. And so in general, this angle here is going to be 2 pi over n, which means that this angle here is simply going to be pi over n, right? And we know that the length here is simply going to be 1 over n. Therefore, we know that this length here is going to be 1 over 2n. But we want to find r in terms of n. Now, we know using r, so let's draw this right angle triangle out a bit better. So we're going to have our right angle here. We're going to have pi over n. And this is going to be 1 over 2n here, and this is going to be r. So I know that r sine pi over n is equal to 1 over 2n, which implies that r equals 1 over 2n sine pi over n. So now I know what r is. I know that the area of one of these triangles is going to be a half r squared sine of this angle, the 2 pi over n, right? And so I can substitute r into here. So I'm going to have 1 over 2n sine pi over n squared times sine of 2 pi over n. So this is going to give me 1 over 4n squared sine squared pi over n times sine of 2 pi over n. Cleaning this up, I'm going to have sine 2 pi over n over 8n squared sine squared pi over n. Now, we're almost done. We've found the area of one of these triangles, right? One of these triangles that make up our n-sided polygon. Which means we need to multiply this by n to get the total number of triangles that make up our n-sided polygon, and therefore the area of our n-sided polygon. So an is simply going to be, if I multiply this by n, one of the n's in the denominator drops out. So I simply have sine 2 pi over n all over 8n sine squared pi over n. Now, we need to find the limit as n tends to infinity of a sub n and interpret this geometrically. So let's have a go. So the limit as n tends to infinity of a sub n is equal to the limit as n tends to infinity of sine of 2 pi over n all over 8n sine squared pi over n. Now, if we consider the sine functions, as n tends to infinity, 2 pi over n tends to 0. In other words, our argument is very small, so we can use this small angle approximation, for sine. So we know that sine theta is roughly theta in radians when theta is small. So this is going to be the limit as n tends to infinity of 2 pi over n over 8n pi squared over n squared. Cleaning this up, n tends to infinity of, so this is going to drop out, give us a 1, this is going to become a 4 here, and then I'm going to have pi over 4 n squared times pi squared over n squared of, one of the pi's are going to drop out, obviously the n squareds cancel, 1 over 4 pi, so that's just 1 over 4 pi. Now we need to interpret this geometrically. Well, let's go back to what the question was actually asking us, right? We're finding the area of nth regular polygons with perimeter 1. You can imagine what this is going to be like, right? Geometrically, as we increase n, as we make the number of sides increase, this is going to tend towards a circle, right? And so I believe that this is going to be the area of a circle with perimeter equal to 1. Can we check our hypothesis? Well, what's the area of a circle? We know the area of a circle equals pi r squared. And we know that the circumference of a circle is equal to 2 pi r. So we know r is equal to c over 2 pi. Now, c... Oh, whoops. Oh, there we go. C is equal to 1. Okay, so we're going to have 1 over 2 pi. So if we substitute that into here, we should have a equals pi times 1 over 2 pi squared, which equals pi lots of 1 over 4 pi squared, which equals 1 over 4 pi. Isn't that remarkable? So, a very, very interesting question there about nth regular polygons with perimeter 1. Let me know how you found this in the comments, and if you want, I can go through any specific topics, so do let me know. See you in the next one.